Alright, so begins another draftphysics.com video presentation. I guess the chat has already popped out, which is not really legal. So I'm going to have to fix that. Sorry. Gotta waste a little bit of time because something's broken. It's not giving me any... Yeah, there it is. Alright, now I have to do this and this. So... now it should be okay. Alright, so, PhysicistMichael. Yeah, I understand you don't want to do this arguing thing. Yeah, no point in people insulting each other's mothers or anything like that. I would just say as part of this circumstance, because I'm a dissenter and I'm opposing the religious theory that must be believed by everybody, people have gotten very aggressive in attacking me and invading my personal life, and it's it's just part of what your gang does, and the believers do. And that's just a fact. Now, the fact that people who disagree will end up calling each other names. I mean, Professor Lewin, an MIT professor, called a person who has a doctorate in electronic theory, or electric theory anyway, a flat earther because he dared to disagree with him. So I mean, some of that is just you've got to accept, I think, as part of the argument, because basically this all started with an argument 350 years ago, and I'm still fighting that fight because I think the wrong side won, and it won for no good reasons, all bad reasons, and it's all bad science. And they certainly called each other, free energiers. Okay, they certainly accused the other side of making a fundamental critical error and doing it for not very good reasons, in the sense that they didn't have any evidence to support what they were arguing, and they were arguing it for reasons that weren't purely scientific. It's truth they want to be true. It's not that it is true. So anyway, I'm clearly not interested. I don't make videos crucifying people or insulting people. I draw constantly on the board, and then you sort of insulted that. Your little pictures, you call them, or something. So I'm just saying, you can sit there and claim yourself to be perfectly innocent, but I don't know if you are. So it doesn't, I'm just saying, it doesn't matter to me. I can take a little bit of this contentiousness. We don't have to even like each other. But frankly, I don't have anything against you. But I'm saying overtly that your physics is wrong, okay? That what you're saying isn't true. And again, you can show me all the contrived math and other stuff, and I'm going to call it what I think it is contrived, and I'll call the experiments sloppy, because I don't think they can match with other experiments. I don't think it has any continuity. I think if I accept what you're saying is true, I believe I can make a free energy machine based on your theory. Okay, so that has to be resolved. You have to show me that I can't make the machine. All right, so this is just about MV, all right? So if you're going to do an experiment, it seems to me if we're arguing about 1/2 MV squared, or MV being the truth regarding what energy is, then the MV part's the only part we really need to see in an experiment. All I need to see is a mass. I need to know what the mass is, and I need to know what its velocity is. And every one of your experiments is showing me something else. Okay, it's not showing me just the velocity. That's all I need. I can do the calculation. I can do the 1/2, and I can do the squaring thing on my own. I don't need you to do all that crap for me. I need you to show me what the actual velocity is, and then I can understand your claim. All right, so I have some stuff drawn here, and I'll have to put it in a place where I can see what you can see. All right, now, one of the experiments you showed, you said the momentum is conserved. So he did an experiment where he's basically doing the spring in between the two object thing. And so he does it in one case with light masses and the other case with heavy masses. Okay, and he doesn't use anything like 1/2 the mass, and he doesn't even have these to be the same mass, so it's pretty sloppy. in terms of making it more difficult to understand the dynamics of the experiment. But it's close enough. This is more than twice the weight of this. And then he says, well, the momentum is conserved because the same energy goes this way as goes this way. But no, in the two experiments, there's a gigantic difference. Okay, these numbers right here. Gigantic difference in how much momentum was produced by the spring. So he basically is overtly saying springs do not conserve momentum. You could put a certain amount of energy into the spring, that is a certain amount of momentum into the spring, lock it, and it can produce various momentums out depending on what you put on the spring. And I'm arguing that that's not how springs work. These numbers are, 1538 versus 2637. So with the heavier objects, you got a lot more momentum, a lot more. And you could just assume that if it goes even heavier, he'll get even more momentum. And if it goes lighter, he'll get even less momentum and start losing more and more momentum. Now, guns don't work that way. This is supposed to be basically, Richard Feynman would say, the spring is just like a little charge of dynamite. So are we going to say dynamite has variable amounts of energy based on what kind of object you push with it? I'm going to say that isn't how it works. So clearly not a conservation of momentum. You're just showing us that there's different amounts of energy in the spring, different amounts of ability to push masses a velocity. Clearly not the same. If it was gravity or something, we'd say, how much is it? How much force is it? The force is in the spring, and somehow the force is producing different momentums. I'm saying that can't happen. So there's a flaw. There's something wrong somewhere, because that's not how it works. So the simple thing that would solve all this is an understanding, okay, that this is just about hitting masses into masses, okay, with velocities, and there's rules, okay? So we can do the Newton's cradle thing. So that would be this one right here. Okay, so let's say I had a hard rubber ball. Let's get the springs out of it, and the ball's really, really elastic, springy. And I bang it against a steel ball, and they have exactly the same mass. Well, if I build the Newton's cradle out of it, the energy goes straight through. Oh, this marker's finally had its its run. Well, we'll try to get through. Because I don't know if I have another one handy, frankly. I have to find something, I guess. So yeah, the energy stops here, this stops, and the energy goes into the other object, and the steel ball flies off. So it's a 100. So if I have 100 momentums in, I get 100 momentums out, and that's all. So let's start making the steel ball a little bit heavier. Okay, and I'm going to argue then, well, we know what's going to happen. I'll put the 100 in, so it's the 100 in always, and I'll get a little bit of a reflection because it can't get all the energy into the heavy object. It just won't go in there. It doesn't work because this can't go the same speed. It has to convert the speed of these atoms. These atoms have a speed. These atoms can't do that speed because that's extra momentum, so they have to do some lesser speed. All right, so they can take a portion of the energy, but they can't take all of it. And whatever's left over, frankly, just reflects. This is what I'm contending. I want you to draw this picture and explain what you contend happens. And as I make this heavier and heavier, I'll get to some point where half, okay, the momentum will go this way and half the momentum will reflect. And then it'll be more reflection. The heavier this thing gets, the more I just get all reflection. And if I finally make it a dead stopper, I get 100% back. The super ball just bounces back and nothing. This one doesn't do anything. So the more this side yields, the more this side has to lose in reflection until you get to the perfect state where it doesn't reflect at all and 100% goes forward. And then you go the other way with the same logic. That if this starts getting lighter, I still can't get all the energy in it. Besides, this doesn't have enough. This is going 30 miles an hour. This needs to go 40 to take all of the energy. It can't go 40, so part of the energy has to, again, stay here. But it's going in the same direction now. So now you don't have a reflection, but you have 90% of the energy will go into the first object, and the other one will lag behind. And the lighter and lighter I make that, the more and more that happens, till there's a point where 90% is still in the big thing, but the little thing is so small, it's really easy to push. And so I have a tiny reduction in the speed of both objects. All right. But they're both going in the same direction, where here they're going in opposite directions. And yes, relatively speaking, it's just about separation. And the fact is you could draw this as a relativity diagram, but it's a little more complicated. It'd be better if it was in a simulation or something, frankly. But it doesn't really matter. The point is that you need to draw this and explain what your theory predicts. Because Professor Lewin will tell you there's twice the momentum energy in this direction as there is going this way. So somehow you have 300 momentums tied up in here somewhere, when obviously this didn't move, so it doesn't have any momentum. And the fact is I can never get back more than I put in. So I'm putting in 100, and that's all I can get out of the experiment. And it doesn't matter what direction it's going. It's always energy. Any movement in a direction in a vector is energy, and there's no such thing as unenergy. You can certainly do something, go this way, and then you can go back this way and end up where you were. But both of those actions are real actions. They don't undo each other in any real sense. Okay, you can't pretend that you can make more energy. And again, I gave the illustration in yesterday's video that I just shoot something in between the two objects, and I cannot create more momentum because momentums are going in opposite directions. Opposite direction momentum is not canceling in the sense of undoing the energy of each object. Each object has energy. It has to all be accounted for. You can't make more momentum in the universe. You have to use something's momentum to make momentum. That's my argument. Alright, so then I'll draw the rest of it. But it would be helpful if you did this. You know, you can do an unlisted video, if you don't want anybody else to see it, but the people in this argument, you don't have to make it public. You can make it unlisted. I can't believe really that you people can write all this stuff, okay, and it takes you less time than just to say it in a video. So I don't know if there's anything I wanted to save in that. I'm just saying it was a huge difference in the momentum. So he basically did another one of these kind of free energy, free momentum experiments where he hits something twice as heavy, and its velocity, okay, isn't half. So he hits something twice as heavy with the same force, presumably, and it leaves with extra momentum, frankly, because it's not going half the speed or less, it's going more than half the speed. I'm saying in this physical universe that can't really happen. It's not possible. Okay. So whatever your experiment is, it has a flaw in it. If that's the result you're getting, I'm not going to call it shenanigans, but frankly, it's physics and it really should be done right. So it shouldn't have glaring flaws in it, like dropping round things into clay. I could ask you, this is the big experiment that got this thing off the ground in the 1700s, was they dropped round things into clay. Now, do you think it would be the same if they dropped a square thing into the clay? And it doesn't penetrate all the way into the clay. It only penetrates partially into the clay. Can you understand that there's a physical dynamic that's going to be different between these two objects, just like there would be a difference between a pointy object and a flat object, and that this isn't a very good test of a truth? Can you concede that? That dropping round things into clay might not be a very good way to see what the total destructive power, whatever you want to call it, that the fact is it'll create the illusion, just like rolling objects on the surface. I've used these examples and you're not going to reply to them, and then you're telling me you are replying. You're not, plainly. I roll an object, okay, I've done this, and and it gets ignored. Okay, I give it one velocity. Okay, all right, I give it one velocity, and then I give it 2 velocity. And yeah, this goes 4x further. But did it really do 4 times the work? So it's going 0 here, okay, and it started with 1 velocity here. It'll have 1 velocity here. So it's going to be going half the speed, okay, 3/4 of the track, three-quarters of the way down the track. Isn't that sort of a giveaway that this isn't linear? That you're not losing the same energy per foot? That you can't do a calculation based on distance and get a right answer because the amount of energy you're losing per foot changes as your velocity changes. And you lose a lot here because you're sitting in the gravity, and you lose very little here because you're zooming through the gravity. And the same is true in dropping the object. It's reached half its velocity here. Okay. It's only going to get 1/2 the velocity for this entire trip here. Only a half increase for all of this distance, the 3 distance, okay, and it gets half the velocity here. And isn't it a glaring giveaway that this isn't linear? That it's not getting the same force per foot? It's not a per foot force? And it takes exactly 2 seconds time, 4 times the distance, twice the time, twice the weight, twice the what's the other thing? Twice the time, twice the weight, twice the velocity, and I would say obviously twice the energy when it hits the ground. So I want counter arguments to these arguments. Okay, I mean, you providing some experiment I've seen 44 versions of that all got semi-different results isn't, in my opinion, compelling evidence. I mean, you don't know the history, but I mean, there's a Professor Lewin video, and he does the same video you just did with banging this cart, except he has more precise weights. And there's obvious glaring bizarrenesses in the sense that it's a clump of clay blobbed on the cart. The carts are precisely cut, the pieces are engineered. What's the clay doing there? Anyway, alright, so what do I want to draw now? So this is what I'm requesting from you, okay? Is, for 2 years I've been asking people just to do this simple analysis of a lever. And I put a 2 mass, and I could put a 2 mass, or a 3 mass, or a 5 mass, and I put it the same distance. It oscillates just fine. They weigh the same, 2 and 2. Okay, but now if I change that, and I put a 1 mass out here, same velocity, they oscillate with the same velocity. So I put a 1 mass out here. Alright. Now it oscillates with exactly the same velocity. Okay, I mean, any motion here is this small motion. Motion here is a big motion, twice the velocity. No doubt about those rules. Same thing for gears. I have a gear and I have a small gear. I can make the ratio 2 to 1. Okay, and so any movement here is going to be twice the movement in the same time as any movement here. And the fact is you have to conserve the momentum here. So it oscillates perfectly. Momentum says it makes perfect sense. And the fact is if I was to put in enough energy to cause these objects to actually launch off the lever, that this one would leave with twice the velocity that you put in here. 1 velocity here. And that's the way levers work. They conserve the momentum. They do what the Newton's cradle can't do. The Newton's cradle can't convert, the speed of a light thing hitting a big thing. It can't do the conversion. The lever does the conversion. It automatically compensates for the difference in the acceleration times. This is, if this was accelerating, see the 2 mass, this part of the lever, when I have the 2 mass here and the 1 mass here, this part of the lever where the 2 mass was is going to move identically as if I had a 2 mass here. I could just draw it as a virtual 2 mass, and everything the lever will do will be exactly the same with the one mass out here than if I had the two mass here. The lever is going to move exactly the same exact speeds, the same exact acceleration, same everything. Because the two mass is basically saying you have a two mass over here. It doesn't know any different. That's what it sees as a weight, okay? Because I've converted the mass into a different weight, all right, by changing this speed part. The part of the momentum has been changed. The weight is momentum. I mean, I'm going to argue that weight is momentum, and I think that's demonstrable. But I'm just saying, you're saying this machine does not conserve energy. That if I did plow a 5-ton train, or a 10-ton train, I have a 10-ton train, a 10 mass, okay, with a 5 velocity. You're saying if I put a 5 mass here, I'm not going to get a 10 velocity. No 10. I'm not going to conserve the momentum, because this object only has half the energy of this object. Should have done it the other way around, right? Yeah. Okay, so this is, I have the 10 mass, and this has, and this can't leave, a 5 with a 10 can't happen because this would be free energy. So you're saying this leaves with 1.4 the velocity. Much short, way short of the higher velocity. It comes out 7 or something. Because you have to make kinetic energy rational. And I'm saying, no, what will really happen is I can put the 10 mass going 5 miles an hour, I can crash that into this part of the lever at this location, and if I put a 5 mass at this location, it will in fact leave with 10 velocity, even though your theory says that's twice as much energy. And it would be free energy. All right, one more argument to Michael. All right, now I've been over and over and over this free momentum experiment, and I'll just go over it one more time. So you're taking a 1 mass, okay, and you're banging it into a 2 mass, and then you're saying, if I make this exactly double, that the fact is I can have 100 momentums here, and when the 2 mass leaves, it's going to have 133 momentums going this way, and this is going to reflect with 33. And you're telling me that this energy undoes that energy, that somehow it's not energy in the universe because they're going in opposite directions. They somehow canceled each other and you still have 100. I'm clearly arguing that no, you have 166 and you've made free momentum. So the argument would be is that I could make a little pendulum experiment, doesn't really matter how I do it, and I just keep making the objects twice as heavy. Okay, you can see that, yes. All right, so I can start with 1 ounce, then 2 ounce, then 4 ounce, then 8 ounce. And by the time I'm here, let's say it's up to 200. It might take 5 things to get to 200, but I've had 100 momentums in. I'm up to 200 now, momentums. I just put a lever here, okay, with a fulcrum, and I do 4 times the distance here, or whatever, to, do the conversion. It could be just 3 times if this is only 200. I just have to do twice. All right, I just put the lighter object here again. I put the 1 ounce object out here. Okay, so the fulcrum's here. I put the lighter object further away, okay, and just repeat the experiment. So this has 200 momentums. I'll have 200 momentums here starting, and then I'll just do the same thing again. All right, and then back into the lever again. All right, now what I want you to tell me is, why won't this work? What fails in this free energy machine? Right, I'm going to have 200 here. Now, because I'm shooting up the lighter object again, even your kinetic energy theory would kind of imply that I have to, well, anyway, to conserve your kinetic energy, you break the momentum. But I'm just saying, if it happens my way, clearly I gain kinetic energy just from the lever itself. But anyway, let's just say it's 200 here. Okay, then I got 400 here, and then I start out here, and then I got 800 here. I just keep doubling and doubling and doubling the amount of energy, and it just goes forever, and I can just siphon off a little bit. I can put a little damper on here and just eat a little bit of the velocity and create a free energy machine. So why won't the free energy machine work? And again, the only way you can make it not work is to do your 1.4 thing. Okay, and I don't think there's any way that you could show that in an experiment this doesn't leave with twice the velocity. So I don't think there's any chance levers don't conserve momentum. But anyway, all right. So now I'll read comments, and I'll probably start with Piro's comment, and then I'll get to PhysicistMichael comments if he's interested. But I mean, to me, this is the story. Okay, the story is a 350-year-old story. It has to do with the fundamental dynamics. Momentum is built into your theory. It has mv in it. So we're really just arguing about what masses and velocity, what happens. Is that conserved? That has to be conserved for there to be conservation, in my opinion. You're saying you conserve it through your square and your half, your distortions of the mass and the velocity. And I'm saying, no, you can't fix it that way. The mass and the velocity is the stuff that has to be conserved. That's the stuff Newton, Descartes, and Galileo saw conservation in. And they weren't wrong. Again, you could explain the history, all right? Why don't you do a video on the history and explain to us why they didn't see it, okay, the mv squared thing, why the living force, they were blind to it, couldn't see it. Why don't you explain why they couldn't see it? Why couldn't they see that it took 4 times the fuel to go twice as fast? Why didn't they notice any of this if it's such hard physics? And you could maybe explain why that happened, what key event took place that kept Newton in the dark, where he didn't do sufficient experiments. I mean, Descartes banged stuff into each other for years. Why didn't he notice, this squared factor? That would be a good context here, but instead you're just saying that our authorities have decided this is the truth. And again, you're not showing any elemental physical proof of it. You're just showing us your mathematical proofs, but you're not showing us any physical proofs. You're not showing the 10-ton train lighting more light bulbs. I mean, the 5-ton train going 10 miles an hour lighting more light bulbs than the 10-ton train going 5 miles an hour. And I'm just saying, you're sort of insulting my intelligence to say, why am I not, frankly, as easy to convince as you are? And, I'm sorry, I shouldn't be that easy to convince. I should say, show me. You're saying there was something wrong with Newton's physics. You're saying he got wrong answers. Well, why don't you show some of his wrong answers? Show where he miscalculated something because he didn't do the mv squared thing when he decided how 2 things bang off of each other. Show his errors if you're going to claim he made them. All right. That would be my challenge to you. That's my counter argument, is that you have an elemental misunderstanding. I mean, I could make the gravity argument all day long. I mean, it's 9.8 meters per 1 second. Okay, so every 1 second you get 9.8 meters of velocity. So after 2 seconds, which is the time it takes to drop 4 times the distance, if you drop 1 distance in 1 second, you drop 4 distances in 2 seconds. It's only 2 units of gravity. It's only 2 units of 9.8. So you're telling me overtly I should believe that 2 units of 9.8 equals 4 units of energy. Isn't that what you're overtly telling me I am kind of stupid for believing? I have a misunderstanding that 2 equals 4, and I think 2 equals 2, and you think I should believe 2 equals 4. So do you understand why? Now, I'm sorry, until you show me 2 equals 4, until you show me 2 units of force equals 4 units of energy, why should I believe that? That's the best I can do, I think. All right, so off to the years worth of comments. I mean, just years and years and years. So these are the experiments. So he doesn't, like I said, none of these graphs have actual velocities in them. They all have some sort of mathematical interpretation of the velocity. And yeah, so not very useful. But I'm not saying his velocity numbers are anything different than what his machinery has recorded. But I will say that I disagree. That it doesn't really happen if this experiment is done better. These results are wrong. Okay, and you could sort of see. I'm saying, look, you can't. He has the video in an inset. Okay, you can't do anything with it. Can't do frame rates. But if you play the two videos, it clearly looks like the much heavier parts are going half the speed, not more than half the speed. You know, something half or less, not half or more. That's how it looks anyway. But I'm just saying that theoretically, if you can make free momentum, then I can make a machine that exploits it. Okay, yeah, that's all I need to say, I think. All right. So is this the right video? No, this has 0 comments, so it can't be the right video. Here we go. All right, so Piro followed up to his other comment, and it's just so, I think it's impossible to understand why people do what they do and say what they say. I can't understand it, and it's so unrelated. It's not the same subject, frankly, but whatever. We'll deal with it. Hi, Gary. It seems I didn't do bad trying to explain some of the aspects of your ideas. Well, I mean, the simple aspect is I'm saying all of your science is a bunch of fables that you haven't done what the scientist is supposed to do, which is provide evidence of them. So it's all unevidenced theory. You tell me light is bent twice as much by gravity, but you don't show me it is. All right? So I'm just saying, you don't show me. You say Thomas Young analyzed the double slit experiment. I'm saying, no, if you look at what he analyzed, it's a single slit. The pattern's a single slit pattern. He didn't analyze a double slit pattern. So it's just silly to say the Young double slit experiment because, frankly, it's not a double slit pattern. It's not a double slit fringe pattern. I mean, it's full of this nonsense. And kinetic energy is just another example of just a bunch of unproven claims you're going to make about reality. And frankly, Newton was right, and Galileo was right, and Descartes was more right than you people are anywhere close to being. And, they didn't even have light bulbs. Although I disagree with them. Yeah, you don't disagree in any kind of civil, decent manner. You just throw a bunch of insults that I'm anti-science because I'm not a silly dupe like you and fall for every piece of crap some intellectual spews at you, okay? ESP particles. Screw that. All right, the one thing you dispute is not believing in Galilean relativity. Well, obviously I disputed a lot of what you stated, but what the fuck? I mean, why do you, I don't know why you think why are you badgering me with Galilean relativity? What do I said it as so clearly as possible. I believe in an absolute three-dimensional universe. Galileo basically did too. And so that's it. There's no frames and there's no warping of space or distance. So anything that travels has to travel velocity through actual space. It can't get anywhere instantaneously or for free or any of that crap. It has to go a velocity and travel a distance. And we see things, okay, using a force that doesn't move instantaneously. So yes, there's a delay in how we see things. But that doesn't even have anything to do with this crap. And obviously we can look around and I can have a perspective, and I can have a perspective based on a model of the whole universe, or I can have a perspective that's just narrow in the world I'm existing in. So right now there's a bunch of stuff in this room that's all moving with me in the same direction. I don't know anything about that, but the fact is I can understand it. So, and yes, in this condition, the fact is that we could all be going 500 miles an hour this way, and then one of us can relatively only be going 499 for a minute, and that'll look like they're going that way. But they're not going that way. You're not going to understand that. But anyway, one thing you dispute, okay, Galilean relativity, which is velocity relativity. No, it's an absolute universe relativity. is the idea that if two objects are moving toward each other in space, you could say one is moving and the other is still. And why would I disagree with that? You could say it if you didn't look out the window, or you could say it if you didn't have a broad enough perspective to know the whole universe is moving 40 miles an hour that way. But who cares? The point is that yes, with correct knowledge you can know who's moving. Without complete knowledge you can't tell who's moving. So this is just the passing train thing. Yeah, you can't tell who's doing what, with any precision unless you have some other reference to compare the two trains to. All you know is that you're passing at a speed. You don't know whether you're going 60 miles an hour, they're going 60 miles an hour, or whether you're both going 30 miles an hour. You don't know for certain. Okay. Or that it's, you certainly could know if you hear clickety clickety click under the floor. If you feel the train moving, well, you could figure it out that you're going some part of it. Okay, or that it's the other way around. The other moving object and the first one is still, or both of them are moving and at half the relative velocity. So again, all of this means nothing to me. I don't know why this is an issue for you. I don't know what the fuck you're talking about. I've made it so explicit. I believe in a three-dimensional physical universe. There is no undue space. There's no frame space. There's none of this crap. You can't change the distance between things without physically moving through the physical universe. Why is this at all complicated? And the light that you're communicating with is just baseballs, essentially, that you throw at each other, that get thrown to you, and so you understand that it takes time for you to see somebody else. That's it. What's so complicated? It has nothing to do with breaking the fact that there's a three-dimensional absolute universe, period. Okay, I know you don't agree with that, right? So where do you know this from? Where did I ever say anything to imply that I didn't say people can't be fooled? Of course they can. Where did I say some things don't seem like? Of course they can seem like. I'm saying a scientist should know I shouldn't be fooled by seems like or looks like. And I should actually prove that it is like. So I'm not wrong about you disagreeing with it. Well, of course you are wrong, and you have no quote, and you have no reason to believe this crap. And there's no reason to think Galileo was an Einsteinian, because he wasn't. You might not think Galileo said that. No, I've read what Galileo said, and he left it an open question, frankly. He wasn't sure whether this was a phenomenon that breaks three-dimensional reality, or whether it's just a phenomenon of the fact that there's three dimensions and this is the way we see things. Okay, but he did. So again, you can say I disagree with it, you can say any of those lies, and you haven't proven any of them. I can't imagine where you're getting this from. What fucking video I ever made to imply I don't believe in three-dimensional space and the fact that in certain circumstances with limited knowledge, you're not going to be able to tell who's moving. Of course, that's true. That's why we talk about building a light clock in a spaceship or some other mechanism that'll tell you exactly who is moving and who isn't moving. The spectral part of this is there is no place to put the 0 point or origin point of our space coordinate system. I don't have to place it anywhere. I just imagine an object that isn't moving. The end. You put an object that isn't moving, that doesn't have a velocity somewhere in the universe, and then you can just say, boof, there's my reference. Any place is as valid as another. So what? Again, how's that a problem? You disagree with that as well, correct? No, I don't disagree with that. I don't know even what the fuck you're talking about. Relativity, as Einstein created it, is an entirely different theory that creates warpages and frames and other kinds of nonsense in space that has absolutely nothing to do with changing with the unchanged three-dimensional universe Galileo was imagining. The fellows from the velocity relativity, this follows from the velocity relativity, because if there was such a point, then you could calculate absolute velocity. Yes, of course, and Galileo didn't deny you couldn't do that. He again was pointing out if you have no reference, right? He didn't talk about you sailing in the boat and watching your boat sail and looking out, just standing on the deck watching the land go by. He wasn't speculating about the land moving and all that kind of crap. He was talking about, inside the ship, you couldn't tell the difference. If you're inside the ship and you open a jar of bees, they're going to behave as if they're not moving 30 miles an hour with you. Okay, it's not going to appear they're moving in any direction. Okay, which Galilean relativity is claiming you can't. So, frankly, prove it. That's why I said you disagree with Galilean relativity, and now you know what I mean by Galilean. No, I don't know any of that. I don't know why this is relevant. I don't know what it could possibly mean. I don't know how I could be any more explicit. I believe in 3 dimensions of solid space, in the sense that it's nothing, space is nothing, but you can't traverse it for free, and you can't traverse it instantaneously, and you can't change how much distance there is between things. They have to have a velocity to move the distance, and the speed of light is constant, and the light always moves the speed of light. And so if you're a flashlight and I move you the speed of light, the fact is the photons aren't leaving the flashlight. Galileo did believe in these things, but that's a separate issue from the type of relativity that predates Einstein and QM. Again, the type of relativity, I can go back to Leibniz. Leibniz didn't believe in reality. That's, in my opinion, your liability, not to your advantage. Okay, so again, just keep talking your woo theory that the reality is, a simulation or some other mush. Okay, it's pretty clear your system is based on an absolute coordinate and velocity system. Yes, that's pretty clear. And so is, again, you can't say Galileo didn't have one either. He said we can't see it. He didn't say there wasn't one, which is what I was explaining to PhysicistMichael. Whatever you were explaining, it's just a bad paraphrase of my arguments. And so in a sense, you're just talking shit that I have to untalk. That I have to defend myself against. P.S., which, frankly, is sort of tacky. You showing up on somebody else's video, typing a bunch of crap that I have to fucking qualify and define and explain. Thank you very much. It just shows how, people have no, there's just no limit to, what little cheats you'll take advantage of. A second is just as different from a second squared as a foot is from a foot squared. So this is his logic. So you can certainly imagine a foot squared. You can understand it geometrically. It's a real thing. But there's no such thing as a second squared. And again, it doesn't change the fact that, sorry, but that's your mathematical rules. 1 times 1 equals 1. Okay, so it's not my fault, but that's your mathematical rules. And the absolute fact is that you are breaking the relationship by not putting down, by not fulfilling your obligation, all right, to write the complete ratio, the complete statement regarding what the truth is. So when you say it, 9.8 meters, it is per 1 second. And you're leaving the 1 second out. The 1 is vital to the 9.8 being true. Any other number besides a 1 and the 9.8 isn't true anymore. So this can't be 0.5, and it can't be 2, and it can't be some other number because you break the ratio. It is 1 second. So if you're going to square the seconds, that is, you're going to multiply the seconds times the seconds, it's 1 times 1, which equals 1. You're tough luck. You lose. So if you do the math honestly, the fact is your square is irrelevant because it's not real anyway, because there's no such thing as a geometric square second. It doesn't exist as a reality. can't square a second. Jesus. So, garbage. So, just garbage. All right, so I did attempt partial response. So PhysicistMichael did write a lot of crap, and I haven't even read it, frankly, some of it. Because, he's just approaching this all wrong, in the sense that he's not getting, I want to re-engage in the argument that happened 300 years ago. Because it's that argument that is corrupt and led to the history that created these beliefs. And I'm saying the living force was accepted as a theory for no good reason. There wasn't any compellingly good physics evidence. There was a silly experiment where you drop round things into clay. One experiment. That's it. No other evidence. And this fooled science. That's the subject. Was science fooled, or did science discover a real truth? Okay, I'm arguing there's no evidence of any discovery. There's just evidence of a little propaganda war, and the fact is the wrong side won. All right. First off, I don't think so. I did respond to this first paragraph, but I'll read it anyway. I won't bother putting it up because it's not that fascinating. I guess it doesn't matter. It's not that much work. Yeah, that wasn't that much work, but you probably can't read it anyway. First off, I don't think I've offered any direct insults to you. Okay, you mocked drawings, and you did in fact keep saying that I have some misunderstanding. Okay, you're being very patronizing in my opinion, and the point is I don't think you're directly responding to any of the direct challenges I'm making to your theory. I'm saying your theory doesn't work in space. Can you explain how it does? That if you have a spaceship and you're going to navigate, and you're going to navigate by throwing stuff in your room out the window, does kinetic energy work? Okay, if I have, I apologize. I don't support anyone else offering insults either. Well, like I said, whatever an insult is. I mean, one man's insult is another man's compliment, and so, but whatever. I do try to keep the discord elevated. Yeah, I try to keep it on the subject of physics, frankly. Okay, I'm attempting to point out the errors. So, again, you're saying I'm attempting to point out the errors. I'm just saying, doesn't that sound... that's exactly what I'm trying to do. I'm trying to point out your errors. That isn't going to rub you a little bit wrong. My presumption that you're error-prone and, you're silly. Yeah, we're both going to end up insulting each other. There's no way not to. We're challenging a fundamental belief. I'm basically saying your Jesus theory is bullshit. And you're saying my Jesus theory is bullshit. Okay, that's what we're doing. I don't think we can be non-offended. All right, in your ideas by offering evidence. Well, I'm saying to you, I said already, I've watched every single Professor Lewin video online. I've also watched numerous, 100 videos from other university professors. Okay, I have seen every kinetic energy experiment ever performed on the internet. I've been doing this a long time. I'm not ignorant. You can say I'm wrong, but I'm not ignorant. I'm going to try one more time to summarize the experiments that I've presented. Okay, they're the same exact experiments. Okay, there's nothing new. You're not showing me a new experiment with, that has some intrinsically good value, like you're going to show me it taking 4 times the fuel to go twice as fast. You're not showing me anything that gets to the elemental question. Okay, and point out where those experiments directly contradict various statements you've made. Well, I'm going to argue that your experiments are fundamentally flawed, okay, because I'm going to argue they're not consistent with other people doing exactly the same experiment. All right, and I can point out how I can show you 20 different experiments, all done scientifically, and all of them getting inconsistent results. This is for both the video and the follow-up that I posted this morning. So the follow-up is inherently valuable if you're going to stand by it. Okay, because yes, in my opinion, you have shown that your physics believes in free energy. Okay, and that I should patent it and make $1 zillion because you're opening the door. You're saying the physics provides you the opportunity to make a free energy device. And I hope you will consider these points. Well, duh. I've obviously considered them. I'm play your whole fucking video in some cases, and I'm perfectly willing to respond to any challenge you make to me. But whatever. First video. Testing the claim was that the standard physics definitions of work and energy, that the net work is equal to the change in the kinetic energy. That is, well, obviously I'm pointing out, I don't think your work equation has anything to do with reality, because it's not force times distance, it's force times time, and it's clearly the case in anything using gravity as the energy source. So if you're going to use gravity as a storage device or a source of energy, clearly gravity, the work, okay, is completely time dependent. Okay, this is the area, the F versus X graph equals the change in 1/2 mv squared. So again, I don't care about this. Well, I don't care about your calculation. I care about the m and the v. So just show me an experiment where you show us the actual mvs. Because that's all that is real in any of this conversation, is the mass and the velocity. All these other abstract aspects that you can create, this 1/2ing and squaring thing, I'm not terribly interested in, frankly. I want an accurate statement regarding what you claim the MV will be before and after. What's your prediction about an MV? I tested this 3 different times while constant forces are applied. So again, it's the same experiment, yes, 3 times. Who cares? Nowhere did you collect the joules of energy. So again, you're just going to tell me what you mathematically calculate. I'm not interested. And then you're going to say it has to be right because both of my rotten formulas that were contrived, okay, you're not going to give me the history of the work equation, and you're not going to show me the history of 1/2 mv squared. Provide me Leibniz's brilliant arguments. Okay, Leibniz, the guy who believed in solitons and monads. He believed little spiritual objects ruled the universe. Physical objects had little souls in them. Okay, that was his theory. So argue his theory. Anyway, and once the force is, and once with a force that changes with position. We already did this. Okay, I already responded to your video. I don't really want to do it a second time. I don't think the experiment is an illusion because you're not calculating how much energy, because the speed of the object falling is constantly changing. It's obviously in the gravity, longer or shorter, and the amount of time it's in the gravity is what you're really collecting, as I pointed out in my video. All cases match within a few percent. So again, a few percent of what? My work equation, that is a piece of garbage, got the same answer as my garbage, 1/2 mv squared. I'm not surprised because the work equation was completely contrived to match that equation. So why is there anything? Again, we're just back to the same argument. You're saying that it's 9.8 meters per foot. You're not saying it's 9.8 meters per 1 second or a second. You're saying it's 9.8 meters per foot. That gravity gives me energy every foot I fall, no matter how fast I fall. Doesn't matter how fast I fall, it matters how far I fall. Nonsense. All right. The purpose was to show that work and kinetic energy are physically relevant quantities. So again, I'm not going to argue this. This is nonsense. I'm saying, of course, I'm saying work is just energy, okay? Work is what you call the portion of the energy that you like. But I'm just saying work is always energy. And the fact is that you can have work and waste, okay? If you have 0 waste, then your work will equal your force, will equal the total energy. If you have some waste, then the work will be the portion you call work, and the waste will be the portion you call waste, but the total energy will be both of those things, and the force has to include both those things. The force would have to be big enough to have work and waste. All right. You can use one to predict the other. So this is just circular. So if I know about the forces that are applied over a displacement, so you just keep arguing the same thing. And you're using 4 different words for displacement, the distance, the velocity. You just keep doing it. I can predict how the motion will change, viva the change in kinetic energy, and vice versa. Vis viva is what kinetic energy was called, and its invention. The living force. How scientific. Anyway, this allows us to make testable predictions about how systems will evolve. I mean, again, this has nothing to do. There's only part of your equation that's real is mass and velocity. Those are the only real components of real things happening in the real universe. This fully supports the standard physics claim involving work in KE. So again, he's just going to keep saying the same shit that this proves it. I have this mathematics that I've contrived that I will not talk about its history. This proves it because that math is so credible. And I'm pointing out how overtly the math is incredible. You're measuring how far something falls in gravity, and you're paying no attention to the fact that it's a 9.8 meter per second force, that you get it based on how long you're in the force. How long are you free falling? That decides how much energy you have. Distance doesn't matter. Obviously, there's a huge correlation between the distance, okay, and your eventual speeds and all of those things, but I'm just saying that the real thing the force is doing is obviously there's no correlation between 4 times the distance and twice the amount of time. That has to be understood. It's only 2 units of gravity. You're only going twice the speed. Why would I think there's 4 times the energy? Second video, testing the claim that energy is conserved in a variety of conditions. So he's doing, again, I already made a response video to the video, and he's just dragging it up again and saying the same crap again. So, I mean, what the hell? What does this have to do with any of the challenges I made to you? Nothing. Is there going to be any response to the challenges I made to you? Where I asked you to, explain how this works. What happens in space? What happens when I put 2 guns inside of each other? Or I make a zip gun and have 2 bullets. What happens? Did you do any of that? No. You're just going to keep banging me over the head with this same rhetoric. This old, tired, contrived crap. This was tested with the cart moving up and down the ramp. Nothing was tested. Galileo rolled things down a ramp. That's how he figured out how gravity worked, because he basically slowed down the process. And what he basically showed is, it does a lot more work when it's going down a ramp. It heats the ramp. There's a lot more energy being created because it's in the gravity a lot longer. Okay, involving KE and gravitational energy, and with the cart attached to a spring oscillating on the ramp. So again, we found that at least over a relatively short time before friction has a chance to remove a lot of the energy from the system. And again, that's all friction does, is remove the energy. How? Because you're transferring it. You're moving it from one object that has it to an object that now doesn't. You're giving it to the ground. Friction is not a counter force. Friction is you losing your energy. All right, the total mechanical energy. So now he's using the term mechanical energy. So we have kinetic energy, we have mechanical energy. I mean, what's the point of all this mushy rhetoric? Is conserved. So I don't know what mechanical energy is. Is that momentum? Again, this utilizes the Sanders physics definitions of KE. And again, the whole argument is about what value these definitions have. Are they anything close to being real? So does it take 4 times the fuel to go twice as fast? That's your definition of reality. Is it true? Do you have any evidence showing it to be true? My argument is, of course you don't. And you just keep badgering me and telling me I must believe it even if you don't have any evidence of it. Gravitational potential energy on Earth. Okay, again, this utilizes the standard physics definition of KE, gravitational potential energy on Earth, which you're saying is distance related, that gravity cares about how many feet you travel, not how much time you're in it. Okay, and spring energy. And again, we're disagreeing. You're saying springs don't conserve momentum. I put two heavy objects on the spring, I get a lot more momentum, and then if I put two light objects on the spring. If any one of those were off, we wouldn't expect to get total energy staying conserved. So again, just, you didn't conserve it in the first place, but whatever. This again supports the standard physics claims involving the different types of energy. So again, he just keeps applauding his own, in my opinion, poor logic and flawed reasoning and clearly distortions of reality. Okay, because none of this was proven in any way that anybody who has any kind of fair scrutiny. This is a terrible test. Okay, this is confirmation bias. This is the danger of it. We then looked at elastic collisions between carts and measured both the momentum and the total KE. Why didn't you just measure the mass and the velocity, okay, of the system? You specifically said that this was not possible, and I continue to say you can't make free momentum. That's right. To conserve both momentum and KE. Yes, with unequal masses it's impossible. Because of the square, quite obviously. The squared term makes it impossible to transfer energy between light things and heavy things without losing momentum. It's impossible based on KE. These experiments, for examples using a variety of different masses and speeds, yeah, I would say very sloppily chosen masses, frankly, and speeds, directly contradict your statement. And I'm saying I can show evidence where MIT had to cheat the experiment to make it to work. So I'm going to argue that as much as you think you're a great experimentalist, you made a mistake. Because you didn't conserve the momentum in the one case, which clearly I think you have to. The spring can't make variable amounts of energy. Okay, it has to make the same amount of momentum. That's what went in. That's what has to come out. If I can make free momentum, I can make free energy. I've listed the specific initial and final velocities of each cart in the description. Yeah, too bad you don't show them charted of that video so you can check the work. I can say to you, okay, what I can't check is your whatever. You pointed out how your detectors might be interfering with each other. I'm going to argue that what would be better is if you film the experiment, in higher resolution so you could check it with frame rates, or double check the velocity in some other way. Because frankly, you're just saying my detector says this is what the velocity is. And I'm saying, well, yeah, you're doing an experiment where you're making free momentum. Okay, I'm supposed to believe. But I'm not going to, because I don't think you can make free momentum. All right. So whatever. It is entirely possible to have elastic collisions that conserve both total momentum and kinetic energy. I think that's insanely silly as a statement. So I'm just saying, how is it mathematically possible? How is it mathematically possible to have a squared term? I mean, I shouldn't even have to draw it. But I mean, how can you have a squared term and you start changing the masses and you can conserve the MV, the elemental MV? You can't conserve it with transferring the energy from a mouse to an elephant, or from an elephant to a mouse. It's impossible to conserve both. It's not mathematically lucid to say you can conserve both. All right. Lastly, we looked at cases using springs to launch two cars. You have repeatedly put in big words. Yeah, and I will continue to repeat it. Claim that the fuel needed is related to how much momentum it gains. I've never said that. So I know I've repeatedly claimed that the energy in is the energy out. That's what I'm claiming. The force in is the force out. You can't make free energy. You can't destroy energy. You can't make energy. That's what I'm repeatedly claiming. You can't use twice the force to make 4 times the energy. Claim that the fuel needed is related to how much momentum it gains. I don't even know what that means. You need twice the fuel to go twice as fast. Yes, that's what I'm saying. That's right. You say it needs 4 times the fuel. And in 300 years, you have no experiment proving that. And you certainly didn't do any experiment that proves you need 4 times the fuel to go twice as fast. So I didn't see that experiment. All right. This is equivalent to saying if you have the same amount of fuel but twice the mass, the object should be launched with half the speed. And I'm saying that's exactly what does happen if you do the experiment correctly. But you didn't do that experiment. You didn't have a solid object with a spring, right? So I'm just saying, take your cart and clamp it, and then take your little rickety spring. I mean, I don't want to insult you, but I mean, frankly, you have to concede that this bought-off-the-shelf experiment is a little bit rickety. You don't even know what the spring device looks like, right? So as I've pointed out to Brozo and other, I mean, this is sort of an important difference, and it just, but who cares, right? It's physics. We don't need to worry about details, and you don't have to get too, quality. You don't have to worry about the quality of the observations, the results. Yeah, this works good enough, maybe. It leaves a hell of a mark. All right, so you have some sort of spring with some sort of plunger device, which is a big disadvantage. All right, and so I'm just arguing if you just nailed this spring down, okay, and you're going to compress it a certain amount, all right, now you're going to launch objects. You're saying the heavier the object gets, the more momentum I can make. Okay, so that's your theory. I'm saying no, the same momentum. The spring produces the momentum. So if you lock the spring so it can't go, none of the energy can go this way. It has to go that way. All right, that you can't change the fact that if this is twice the mass, okay, this has to go half the speed, half the velocity. You have to conserve the momentum. All right, so your results are erroneous, in my opinion, if you did the experiment this way, you'll get these results, because springs do conserve energy. All right, so that's my contention. Do the experiment another way, and you'll get results that don't confirm what you're claiming, which is a huge increase in momentum as I go heavier and a loss of energy as I go lighter. Because again, as I pointed out, they already know this from guns and bullets. You can't change. I put 2 light bullets in the gun. I'm going to get a certain amount of energy out, okay, of the explosion. I put 2 heavier bullets in, much heavier even. I'm not going to get more energy out. These are going to move much, much slower, okay? The velocity goes way down, much smaller. I get big M's, little V's, or big V's and little M's, okay? But that's all I can get, and I have to have the conservation of momentum. I'm going to have the same energy here as the same energy here. The gun works because the bullet is going 1,000 times faster, but it's 1,000 times less mass. All right, so very small M, very big V, okay? Big M, little V, big V. I did it the wrong way. The bullet is the big V and a little M, and vice versa. Can't erase with this one. So there's no argument here that you're going to make that you're going to say that somehow there's the explosion doesn't produce the same energy. And of course it does, and it certainly doesn't fail to get the energy into the bullet. You're arguing basically that springs can't get energy into light things. Light things can't push the light thing. Light things are impossible to get the energy into, because it would have to say that the maximum energy in the spring would be the maximum momentum it can produce, and the maximum momentum is to have just a little bit lighter than unmovable. So I go to an object that's a little bit lighter than unmovable, and I'll have my maximum momentum by your experiment's logic. I'd say that's not realistic or reasonable logic. So I don't think I'm going to be able to erase this. No. It's not a permanent marker, is it? Oh yeah, this is the one I'm not supposed to use. Yeah. Oh, that's funny. Yeah, it's funny like the plague. There's not enough crap in this thing. Yeah, I gotta get this. Sorry, I'll have to get this off now before it really sets in. Gotta get the ammonia bottle out. My mistake there. Yeah, I thought it was too good a marker to be a dry erase marker. Why was that? Why is that? Why am I not using that marker? It's so nice and dark. I should have figured that out. Yeah. Well, hopefully not too permanently damaged. Probably have to use Goo Gone or something. Not too bright, Gary. Yeah, I know. Well, whatever. Yeah, that'll do for now. Yeah. So, my bad. I have a ton of markers. I just don't know where I put anything. Where are they? Anyway, I have a ton of them right here somewhere too. Yeah, it should be right here, accessible. It's just funny that, like I said, the one brand doesn't write on. Yeah, it gets all spotty. Unless I use something else to clean the board with, which is strange. Alright, so there's got to be another marker here. I literally have hundreds of thousands. So this one's a dry erase. Let's see if it works. Yeah, that's a good one. Okay. It won't last long, but it'll work. Alright, so where was I? Damn. Okay, when we look at elastic collisions, cards measure the momentum. Okay, of the system, total kinetic. It's entirely possible to have. Okay, no. Lastly, we looked at cases. You know, this whole talking to me like I'm. You know, we looked at cases using springs to launch the cart. So you have repeatedly. Okay. This is equivalent to saying if you have the same amount of fuel but twice the mass, the object should be launched at half the speed. Yes, exactly. Conservation of momentum. This is tested in the compressed spring. Is our fuel in the case? Exactly. And somehow your fuel produces different amounts of momentum. I'm saying that's ridiculous. I ran this experiment with various masses. Yes, sloppily not chosen to be, you know, twice as massive, or a quarter, or some round number. Both low mass, high, and both high mass and different mass cases. And it was the kinetic energy that matched up. And I'm saying that's a flaw in your experiment, frankly, because it's wrong. And if I could test your experiment in some way, then I could show you how it's wrong, because I don't think the frame rates, or I don't think if you used a stroboscope that you could defend this, because it doesn't happen on pool tables, it doesn't happen anywhere else. Okay, or equivalently, when the mass increased by a certain factor. Yeah, it's a gigantic difference in the momentum. So you double the mass, and he almost doubled the momentum. I mean, and it's so backward in the sense that he's making more momentum. The heavier the object is, the more free momentum he's making, the more extra momentum he's getting. And the lighter the object is, somehow the harder it is to push, and it doesn't go. It doesn't make any intuitive sense, that's for certain. The velocity decreased by the square root of that factor. Again, the measurement details, again, they're details you're claiming. I'm claiming if that experiment is true, I can make a free energy machine out of your theory. The details are given in the description, but when the cart masses each went from, yes, these are correct numbers, a factor of 2.7 increase. Yeah, gigantic. Okay, it's almost 3 times the change in the mass. Okay, the velocities went down from 53 to 33. Yeah, it didn't go down very far. So you tripled the mass, and yet you didn't even have the velocity. The velocity still isn't even half the velocity. So somehow I could move 3 times the weight at something more than 1/3 the velocity by your theory. The heavier I make it, the easier it is to push. Okay, a factor of 1.6 decrease, very close to square root of 2.7, which is 1.64. Yeah, I'm saying these results are not real. Okay, I'm sorry. This is just showing how experiments can be done poorly enough, and that the confirmation bias guarantees people celebrating their victory. And then I can show these same experiments done by different people to get completely different answers. So the one where you did the 1 cart into the 2 cart, I can show you a high school experiment where the lady's not even trying to take the actual thing, but she does the experiment, does it perfectly, and it comes out perfectly consistent with momentum. This supports the claim that the energy stored in the spring is converted into kinetic energy. Well, I'm claiming that that's not consistent with what all the professors say. They say you have to conserve momentum. All right, that's what they say over and over and over and over again. They don't say you have to conserve kinetic energy. All right. Of the carts. The spring is converted into the kinetic energy of the carts, and it is not momentum, and not the momentum. So he's saying springs don't store momentum. And so I can make any amount of momentum I want by just changing what I put in front of the spring. So it would be, in fact, take 4 times the energy to double the speed. Well, that's fine. Let's see it work in space. Let's see you do it from a spaceship. Let's see you take a spring and launch different weight objects and see if you can make different amounts of turning speed. That you can use the same force compression, the same amount of energy goes in to compress the spring, you can convert that energy into any energy you want. Just change the weight of the object you're pushing. So I'm sorry, this can't be right. I have tried to show these experiments as clearly as possible. The theory behind them is what's being argued. And there's no way, I mean, you're claiming you basically have proven it takes 4 times the fuel to go twice as fast. Is that what you just proved? I think you just proved it takes, you can go heavier and heavier and gain more fuel by just pushing heavier things. Showing how I set up the experiment, the data analysis, and discussing the results. And again, all of it was, in my opinion, distraction from the core argument, which is we just need to know the masses and the velocities. And they directly support the standard physics concepts. While they don't support the standard physics concept of conservation of momentum, they clearly violate Professor Lewin's statement, you can finagle kinetic energy, but nature can't finagle momentum. Work and energy, and directly contradict many of the claims you've made. Okay, I'm just arguing that, yeah, well, I'm still not convinced, though. So until I see you really, okay, pour 4 times the fuel into the gas tank to go twice as fast, this is, again, just claims you're making with spotty evidence at best. I have no reason to believe you've actually proven it takes 4 times the fuel to go twice as fast. Alright, in the parts of your work that I have watched, I have not seen a single controlled experiment. Why the fuck would I do experiments? I mean, this is like, oh yeah, you want amateurs doing experiments. I can show you lots of amateur experiments. I can show you somebody who's done the same experiment 4 different ways. Okay, batteries this way, batteries that way, this way, and gets different results each time he does the experiment. So he proves a whole different theory each time he does the experiment. Is that what the science should be made out of? Is a bunch of chaos and nonsense? So again, we're back to dropping round things into clay. The only thing that matters is, can you fool somebody? That's the experiment you want. You don't want ones that are credible. I mean, this is like when they say they have done other experiments that verify Einstein's theory of light being bent twice as much. None of those experiments are where they don't shoot the light through a bunch of dirt. And prove that the dirt didn't do it, right? So they're all tainted because they're using experimental data that's tainted by the fact that you're not outside the lamb of the sun. You're not outside the corona. So they have no evidence outside the corona of the sun that light is bent by gravity. A single source of data. So it's all just, these are the distortions they live by. I mean, this is, you're just mocking my arguments. That's fine. You go ahead and mock them, okay? You're not going to take any of them seriously. Fine. All right. The single source of data. Your claims are not data or anything other than that you believe your claims. No, my claims are that I've read every bit of the history and I've looked at all of the related experiments. And I'm saying none of these experiments are credible, frankly. I prove the MIT one to be incredible. Blobs of clay on the cart. Okay, or a single calculation. I mean, again, I could show you the Mythbusters video. They crash a car 50 miles an hour into a brick wall. They crash a car 100 miles an hour into a brick wall. What happens? Does the car crush 4 times as much? No. It crushes exactly twice as much. Okay, what happens? They take clay and they smash it. They crush the clay. Well, they crush the clay at twice the speed. What happens? Well, the clay crushes twice as much. There. Is it proven now? Is the argument over? That's all you're saying to me. So just like you, I can just pick the experiment that verifies me, and I can just say to you, there, it's over. Okay, I win. That's all you're doing. We need better experiments, not more bad experiments. We need some damn good experiments. And again, it's your physics that had 350 years to produce any of this data, and it hasn't. This data. All right. All right. So what is this? Or a single calculation. I do plenty of calculations. They just don't involve halves and squares for the outcome of an experiment that we could go out and test. So again, of course, you can test the lever, you can test banging billiard balls, you can test the Newton's cradles, you can do all of this stuff. I'm not against any of it. So that's another lie. I've done the experiments. I got a pendulum hanging right over there. I oscillated it with a 1/4 mass, 4 times the distance from the 4 mass. Okay, yeah. I have 4 little masses hanging in one spot and 1 little mass on the other spot way outside, and I put any amount of energy in, that doesn't cause it to spin, and it oscillates perfectly. Proving to me that, yes, it's exactly the same thing. A 1 mass going 4 times the speed is exactly the same as a 4 mass going 1 speed. Proves it to me. All right. I videoed that. Other than that claim, you need twice the fuel to go twice as fast, which we have shown to be inconsistent with data. So again, he says he's shown it. He's somehow giving me some indication that it's realistic to believe that it takes 4 times the fuel to go twice as fast. It takes 4 times the work to lift a battery onto a scale. This is 4 times the work, okay? I mean, this is 1 unit of work, okay? This is 4 units of work. That's their argument. This is 1 unit of work. This is 4 units of work. That's their argument. And I'm an asshole somehow because I'm not playing along. They've given me more than enough proof that that's true. I mean, they've made it so clear, it's obvious that it's true, that doing this twice is 4 times the work. Of course it is. 2 equals 4. Anyway, you claim that large swaths of basic physics are wrong. Yes, I do claim it, and it's embarrassing to be human, frankly. It's embarrassing that intellectuals, highly educated people do this. Keep claiming things that they don't bother to prove. Again, the Eddington experiment. You're an astronomer. Okay, you know, you don't need an eclipse from space. There's 400 times better seeing. 400 times easier to do experiment. 400 times easier to do from space. You don't need an eclipse, so you're not going to, you know, all of the eclipses are perfect in the sense that there's no 12 noon, there's no 12 o'clock, there's no 2 o'clock, there's no 10 o'clock. You don't have to worry about what time it is. All the eclipses are perfect. It never rains. You know what I'm saying? I mean, it's a perfect condition, and it takes 5 minutes to do. And you've never your science has never thought, well, maybe we should do that experiment. So it's never been even attempted from space. We've been in space for 50 years, and you've never, well, 70 years, and you've never even attempted the experiment. And yet I don't seem to bring any evidence to the table other than denial of the personal incredulity. And yet don't seem to bring any evidence to the table. So of course I have brought some evidence to the table in the sense that if you're going to force me to do an experiment to prove somebody else is a liar, then I'll do the experiment. But I'm not qualified. I don't have a laboratory. I don't have any crap. So I have to engineer something made out of beeswax and whatnot. Why the hell should science be depending on that? Science is depending on Gary doing the experiment in his fucking basement. I mean, what a pile of crap. That's your science? Billions of dollars, and you're depending on me to do the experiments? I have to do the Eddington experiment for my basement? Oh, shit. Other than the denial and personal incredulity. Whatever. There's nothing incredulous about me personally. Nothing dishonest and nothing but honest. As I've said in a reply to one of your other comments, I'm interested in conversations where both participants are willing to consider revising their positions when presented with new data. And you presented no new data, for fuck's sake. Don't tell me you're providing any new data with your standard out-of-the-box fucking experiment that I claimed and I already stated to you plainly. It's been done already. I can show you the exact same experiments. Every one of the experiments you've done, there are repeats of them multiple repeats of them on YouTube. So don't tell me you brought some new data to the table. I mean, that's so frickin' dishonest. Oh, I should be impressed by your new experiment. No, there's no experiment here. You're just dropping round things in clay again. Here, isn't that good enough? Let's do it again. Let's do the same bad logic experiment over and over and over again. Alright. If you bring something substantive, what is that? Except my counter-argument that everything you're saying about the history of these formulas is not correct, okay? The work equation wasn't derived independent of 1/2 mv squared. They're not independent perspective origins, okay? They're completely biased by connection. All right. If you bring something substantive, let me know, and I'd be happy to keep discussing. Whatever. You haven't discussed anything, frankly. You haven't replied to a single one of my arguments or my requests. Draw a lever and explain how it works. I mean, come somewhere close to what I've actually argued as counter-arguments. I can make a free energy device if that's what you want me to do, but guess what? It won't work by your theory. Okay, because your theory's wrong. Okay, I hope this happens. Whatever. I mean, you really think that anybody who's going to counter-argue you has to in some way, invent something, make a new experiment? They can't argue your theories without having a nuclear accelerator in their yard? Or they, I mean, it's just such bullshit. What have you shown me? Link me to your leader. Link me to the video on YouTube you think is doing it right. Oh, it'll be the one you're doing, the same exact experiment you're doing. And then I'll show the opposite one, okay? You show the one where it comes out your way, and then I'll go find the one where it comes out my way. But if your response continues to be flat denials, so again, they're not flat denials. I mean, it's just such a pile of crap. I'm sitting here logically explaining to you it's 9.8 meters per second. the object is in the force for 2 seconds, how could it possibly have 4 units of energy? How could it have 4 units of 9.8 when it was only in the 9.8 twice? Those aren't flat denials. Those are logical arguments pointing out how your theory doesn't make any sense. Twice the force is 4 times the energy. That doesn't make any sense. All right, without addressing actual data, lie again. I am addressing it. I'm pointing out how you said it was conservation of momentum when it clearly wasn't. You put the light objects on, you get a different momentum number than when you put the heavy objects on. Obviously, the spring is not conserving the momentum. Somehow the spring in one case produces whatever you say it is, 400 joules, and in the other case it's producing 200 joules. How can that possibly be conservation? But your responses can be flat denials without addressing actual data or presenting data of your own. No, I don't have to present data of my own. Again, you've had 300 years to show us it taking 4 times the fuel to go twice as fast. And what do? You show us a contrived experiment of marginal credibility. Then its conservation is no longer. Then this conversation is no longer worth the effort. I told you I was willing to pay you. I'm willing to pay you. Okay, so just tell me how much you cost per hour. Okay, and I'll pay you to draw a lever and explain how it works. I'll pay you to show me Leibniz's great argument. So when mv squared was put on the scene, show me Leibniz's great reasoning. I hope that's not the case. Whichever route you decide to go. Again, I have already seen the evasions. I've already seen all this bullshit. Okay, this is all the same old. You aren't sitting there saying, okay, I'll concede we really should have a piece of evidence. We're saying it's 4 times the fuel to go twice as fast. We really should be able to show that. We really should be able to show that a 5-ton train going 10 miles an hour really does beat a 10-ton train in a tug of war. And it beats it by a long shot. Twice the energy. That's a lot, twice the energy. We really should be able to show the 5-mass object making, twice as much energy. We shouldn't just keep saying it. God. So anyway, I did, attempt a response in text to the first paragraph. Yes, I don't know if it's worth reading it. So we'll go to the chat just to break things up. But, this isn't looking good. But we'll see. I'm just saying, our reputations are sort of on the line because, again, I'm just going to say, if this is all he's going to do is the same experiments we've already seen, and they're all marginal in the sense that I can find somebody else who gets a different number doing the same experiment, or I can demonstrate that the experiment is subtle enough that you don't have to vary or break it much to get erroneous results. Again, I could just show him the Brozo experiment with the billiard balls. Okay, I have billiard balls on a lever. A spring is providing the energy. So the same exact spring force goes into the lever. I put the 2 mass, and it goes 19 frames. I put the 1 mass and the half mass twice the distance on the fulcrum, and it goes 11. 19 and 11. Pretty close to a 2-to-1 relationship, right? Pretty close to half the mass, twice the velocity. Pretty close to conserving the momentum. Let's see. There's not much here. All right. Did anyone provide a good experiment for this lever example? No, there's no. They don't do any elemental physics experiments. So there's no. It's ridiculous, but there's no simple experiments ever done. So they never take a spring and mount it to a wall and then push a mass into it and see how far it goes, and then push another mass and see how far it goes. See how fast it leaves, or push another mass, see how fast it goes. They've never done it. They've never done the Newton's cradle thing. They never took the the same masses and bang them into each other, then take a lighter mass and a lighter mass and a lighter mass and a lighter mass, and then take a heavier mass, a heavier mass, a heavier mass. They've never done it. All right. So what exactly was wrong with his experiments? What do you mean, what exactly? The results are garbage. So what am I supposed to tell you? It's a cart on wheels, and all of the telling of what velocities exist are all done by electronics. So I guess I would obviously say that because we have no way to verify any of the information, I'd say it's something wrong with a glitch in the radar. Okay, it's not even using the electronic data of ascertaining the velocity, is because the device produces an ultrasonic signal and then bounces it off the object. So there's somewhere in there that there's probably some problem. But we saw it. We didn't see it calibrated in any way. We didn't see anything to know that it works, right? Anyway, they contradict your sensibilities, therefore they're wrong. Okay, I'm just going to block you. Okay, so you're done. I mean, this isn't about my sensibilities. This is just such bullshit. It's free energy, asshole. I mean, you don't want to account for that. That's your business, okay? But I'm not going to accept this nonsense that somehow, it bothers my sensibilities. No, it bothers a rational definition of the physical universe. You're saying you can move things without using momentum. I'm saying, well, you have to show me how that's possible. What's the mechanics for it? Because it doesn't make any sense at all. Yeah, fuck you. I'll just delete that one for now. Yeah. Let's see if he says anything else. Where is your evidence that placing twice the mass on the spring yields half the speeds? Professor Lewin. Okay. But again, and why is this my job, right? I mean, you've had 300 years. I mean, Newton probably did this experiment, frankly, but it wasn't videotaped. So the reason why nobody's done it is beyond my explanation. I don't have any explanation for why you don't have the experiment. Okay, that you have to explain. But just tell me what Professor Lewin meant when he said you have to conserve momentum. That's all I'd ask you. So if you say springs don't conserve momentum, I'm saying that's a rather bold claim. Okay? That springs you can push in with a certain amount of force or energy, and you don't have to get the same energy out of the spring. You can get more energy than you put in, or you can get less energy than you put in. You don't have to get the same energy. That's just your argument. I'm saying it's a ludicrous on its face. If you watch this video, he explains it multiple times. So did he do the experiment in one of his videos? Yeah, I did. I launched the 2 mass and I launched a 1 mass with a spring, the same elastic band, because other people were claiming what you're claiming. And yeah, I didn't get perfect results, but I didn't get anywhere near conservation of kinetic energy. So yes, because I'm using 2 balls and this and that, it was more like 1 to 1.8. Okay, so yeah, 20% out of line. But it also, like I said, it in no way confirms that kinetic energy is being stored in the spring either. But it was a very crude experiment, frankly. Admittedly. And, but I'm just saying, go with what you believe. I'm just saying, if you believe what you believe, I'm just saying I can make a free energy machine. So, you really think that free energy could be that easy, and nobody fell upon it yet. Link timestamp. Well, fuck you. I'm not obligated. I have 2,000, 3,000 videos. I don't know. I'm not wasting my time for you. By evidence, I mean empirical real world, not his claims where he just decides a bunch of crap is a fact. So again, you keep making lie statements. I have done these experiments. I made a ballistic pendulum. I did the 1 mass into the 2 mass experiment. I didn't get any free momentum. I didn't get 133 momentums going forward. It didn't happen when I did the experiment. Brozo did the experiment with an air track without springs. Without springs, he couldn't get it to work. So what are you saying? Springs are magic? Springs add energy to the system? Is that your argument, retard? I'm just saying, I'm going to say retard because that's a pile of shit. That's illogical nonsense. He has to make a counter argument. Again, these claims that, like, again, they've had the playing field for 300 years, and then they're complaining because I've been in it for 10 seconds that somehow I didn't water the grass. No, you didn't water the grass. Let's see. So you just believe it with no evidence. You believe it with no evidence. That's the claim. You're saying you believe it takes 4 times the fuel to go twice as fast. You really think the silly little experiment this guy did proves it takes 4 times the gas to go twice as fast? I'm sorry, not even close. And again, NASA proves it all the time, that it doesn't take 4 times the rocket fuel. You're being belligerently ignorant, yes. By asking for evidence? No, by claiming you have any. Yeah. Okay, and we're asking evidence of KE. Exactly. What am I? What I am or am not has nothing to do with physics, by the way. You're the one who brought it up, shit for brain. What about physics have you stated anything here? Except to say you're confident that it takes 4 times the fuel to go twice as fast, even though you've never seen an experiment where that actually happens. The velocity can be calculated from the kinetic energy and mass. So again, that's not my job. I'm just saying if you're going to illustrate the experiment, the essence of the experiment is the velocity. So he charts this stuff and proves it by saying, look at the chart lines. Well, the chart lines are already an abstraction. Show me the raw data, the actual velocity. Now, in this case, it doesn't matter because even when I found the actual velocities, clearly the object that was, he's created free momentum. And I'm just going to make the argument that free momentum is not a physical reality. You can't make more momentum. If your experiment is producing, if your box of experiment has 100 momentums going in and it has 133 popping out, sorry, you did something wrong. It doesn't matter if you have 10 billion megatons of energy going the other way. That energy going that way is a big fucking thermal problem. Okay, you've just made way too much energy in the universe. The velocity can be calculated from the kinetic energy and mass. Yes, okay, we did that. So this is... I don't care. Look, you want to keep arguing? Look, you want me to block you, Merker guy? I've made it clear. If somebody wants to get unblocked, they have to send me a fucking email with the channel that I blocked. What is so fucking complicated? I'm just going to block you. Gary is blocking me, so feel free to put this in his live stream. So now you're going to talk for other little cunts? All right, well then I'm going to block you. There was a NASA video where an astronaut used a spring-loaded tape measure to demonstrate his inertia. See, more lies. With a wrench in microgravity, he accelerated slower than the wrench. Of course he accelerated slower than the wrench, for fuck's sake! He weighs fucking goddamn 300 times more than the wrench, you fucking idiot. Alright, so Merker guy, I don't know what to say. I'm not going to put up with this shit. You're just going to quote crap from other morons and post it on the fucking video. It has no reference to the actual experiment. I can't, anything here at all. And what would I disagree with? I'm saying to people over and over, you Merker, you motherfucker, why don't you post me the goddamn links? Post me to a link that you don't think I can defeat. Post me to the link that proves any of this shit. Science. You bastard. How dare you do this crap? I'm just going to make a generic statement that you have to waste your time pointing out how that's not evidence of anything. You certainly haven't shown where I disagree with the experiment at all, where anything I have said is in conflict with what the NASA guy did. I showed the NASA guy banging tennis balls into each other, didn't I? Did any part of the experiment show anything I didn't already know and I didn't already claim would happen? No. damn, you people are just such pieces of shit. Gary, you're making claims. You either back them up. Fuck you. You're done. You back up yours, you lying sack of weaselly shit. Your fake, phony physics can't put up. Fucker. It's just so silly. I have to prove LIGO is a fake because I have to build a LIGO. Yeah, fuck you. I mean, I could just ask the question. Will anybody ever answer the question? How is it possible to make a ruler out of light where you bang the light into a mirror 1,600 times? So you've now banged the light into a mirror. Now, a mirror means you don't know where exactly, how deep into the mirror the photon will go when it reflects. It could go a little bit, it could go really deep, because it doesn't know which atom it's going to end up hitting. So there's going to be a huge variation. Each time the light goes into the mirror, it's going to be a huge variation in when it reflected, when each photon reflected. How could that be a reliable ruler? I mean, 1,600 interactions with a mirror. Again, I'm just saying, you don't think the ruler is going to get a little bent? 1,600. And then they claim they can measure the distance of the width of a photon, a proton. They can measure the width of the distance of a proton with the ruler that has, you know, variation in it that's just gigantic. So we'll see if somebody can draw a lever, right? We've been asking for 2 years. Somebody can just draw a lever and explain how it doesn't conserve momentum. I find it so repetitive seeing these people keep asking the same thing. Their heads really must be made of mashed potatoes. Well, they're obviously, it's not, you know, they're obviously fanatics. They're just, you know, it's just like the religious kooks. It doesn't matter how many pieces of logic you hit them with. It doesn't matter how many times you try to explain, well, there's this evolution theory and da-da-da-da-da-da. And it accounts for our existence, and you don't need this fable. I can ask them over and over again, where is there any evidence that Newton made a mistake that needed to be fixed? I mean, he calculated orbits, he calculated what meteors would do, he calculated the travel of comets, and he did it all without any mv squared. I mean, how was that possible? Well, Merker guy, like I said, your days are, your hours, your minutes, your seconds are numbered. You just typed a bunch of crap from some asshole who made the accusation that somehow he demonstrated my theory to be wrong. Did he? he makes the claim that I blocked him for no reason. Okay, like somehow it was a violation of his rights to make a video. And you're going to preach to somebody else about the quality of their argument? Your arguments suck. You won't even concede. They really should have done that 4 times the fuel experiment. They've only had 350 years. I mean, it can't cost that much to buy a gallon of gasoline and, see if you can prove that it takes 4 times the fuel thing. I mean, Merker guy, will you even concede that, I've done this rolling ball thing over and over and over again. I mean, you won't concede that this is a pretty good argument? That, if I have, you won't concede that they have an obligation to explain, okay, why what I'm saying right here isn't rationally true. So there's this force of gravity that's going to allow you to lose your energy to friction. Okay, it's how much the gravity pushes is the friction, right? It's completely controlled by the force of gravity. I go 4 times the distance, okay, and I only do it in twice the time. So it only takes 2 seconds to do this, and it takes 1 second to do this. Okay, this is 1 velocity, this is 2 velocity, 2x velocity. Alright, 4 times the distance, and I go half the speed here. So this is exactly what happens here. All of this, the entire experiment, this entire experiment happens here. This entire experiment happens here. And you don't, and this is half the speed, and you don't understand, or you don't think it's a good argument to point out that this entire distance is doing exactly what this distance did. That is, it's the same force, because it's the same time. This is a unit of time, this is 1 unit of time. 1, 1, 1. 1 unit of time, 1 unit of time. Clearly, half the energy is being lost here, and half the energy is being lost here. Is that not clearly what the experiment indicates? And it is 2 seconds, not 4 seconds. 4 times the distance, it's only 2 seconds of time. It's only 2 seconds of force pushing you into the surface. And you can't understand that obviously when you're going fast across a surface. So again, I can do that again, right? I can hold the scale up, but I could draw the scale over here. You don't understand that if I go fast across a scale, the faster I go, the less I'll weigh. You don't understand how it's a pretty compelling argument? You don't think that's true? That I can go faster and faster across the surface of the scale, letting gravity push me down, and the fact is the less time I spend having gravity push me into the scale, the less I'll weigh. It's an absolute fact, and it's absolutely happening here on the ground. These are like little scales. Each piece of distance is just like a little scale. I will push into the ground, okay, based on how much contact I have with the ground, and how much contact I have with the ground, that is how much pressure it feels, is completely dependent on how fast I go across that surface. The faster I go across it, the less pressure, the less energy I can possibly put into the ground. So this is the same. 1 unit of energy here into the ground, 1 unit of friction energy, 1 unit of friction energy here. That's it. Just 2 units of energy. 2. Just as it was only 2 to create twice the velocity. You don't think it's a compelling argument for me to point out that the scale will deflect by me doing this a certain amount. And all I have to do is do this again. Just put another one on the scale. Do exactly the same thing. Use 2 units of energy. You don't understand how this is just 2 units of energy, right? This is just 2 units of energy to do that. They say that's 4 times the energy. I only did 2 units of energy in, and I got 4 units of energy out. You don't understand that's an argument they should counter with some sort of logic. They should somehow logically explain, not mathematically explain, logically explain how I can do 1 unit of energy, 1 unit of work, 1 unit of force, and then I can do a second unit of force, and they somehow are saying it's now 4 units when it clearly says 2 units. I feel we can make an experiment using multiple scales lined up with each other. Why would I waste that? I don't have to do that. I would only have to do that if these people were truly imbeciles. They're not truly imbeciles. They're belligerent, kind of dishonest creeps. But I mean, I think they do understand the argument. I mean, I think they do concede that the faster I go across the surface of the scale, the less I'm going to weigh, because I'm in the gravity less time. And that's why I'm going to weigh less, is because I'm in the gravity less time. I think they agree that that's true. The thing we're arguing is, why won't they admit it? That's the only question. Why won't Merker say, yes, I agree. The faster you go across the scale, the less you're going to weigh. The less the spring will deflect. The less energy that will go into the spring. I think he'll concede that's correct. Using a heavy RC car with a slow motion camera. So, whatever. Go ahead, invent and spare. I'm not against somebody coming up with a good experiment. So not at all. But why don't we just use the RC car to see if it takes 4 times the electricity to make it go twice as fast? Why don't we just measure how much electricity it's using and see if it takes 4 times the electricity to go twice as fast? Won't we be done then? I mean, won't the argument have been decided then? Because we'll have proof that it doesn't take 4 times the electricity to go twice as fast. I'm just saying, do you really think I have to prove to people, beyond just this illustration, that any physicist or anybody rational would argue that this isn't true, that the faster this battery goes across the scale, the less it's going to weigh? Do you really think there's anyone who really thinks that doesn't happen? I mean, if you're there and you really think it doesn't happen, Merker guy, do you really think it doesn't happen? That exactly what I just described. The faster I make this go across the surface of the scale, the less the spring will be deflected. Do you disagree? That's all I'd have to say, right? You really do think it doesn't matter how much time it sits on top of the scale, it'll weigh exactly the same. So no matter how much time it spends, it weighs exactly the same. I mean, of course he doesn't believe that. I don't see how he could possibly be that stupid. No, you don't have to come up with the experiment. Yeah, no, well, I mean, really, this should just be a theoretical. Look, my desire, obviously, I think this is just a theoretical argument. I don't think we should even need to do the physical experiments because the logic is so obvious. You can't make something move in the universe unless you use something else's movement. Nothing moves unless something that's moving gives it its movement. You have to exchange the quantity of motion. You can't make quantity of motion. You can only exchange it. I mean, that principle is just so theoretically solid. I just don't see how anybody logical says, no, that's not true. The scale doesn't change the weight. We're not talking about changing the weight. We're just talking about it's a simple fact. will the spring deflect more the longer I let the thing sit? The faster I go across, does the spring deflect less? There's no other argument. I mean, God, they're so fucking belligerently shitty. I mean, they just really can't help themselves. They are just such corrupt, lying sacks of shit that they will try to make this complicated. This simple argument that the spring is measuring an amount of pressure. There'll be less pressure the faster something moves across the surface. How can you distort that into anything? I mean, they're just, yeah. So I guess the Merker guy won't even man up. He won't say a damn fucking thing. He's just such a little liar. Yes, I'm just saying, okay. So I don't know who you are, Beast Bass. So maybe you already know this is a pile of shit. So, you confess, you conceding the obvious doesn't mean much. We need Merker to concede the obvious. And then he would have to argue, well, yeah, they should explain that, that clearly the force isn't linear. The amount of pressure being put on the ground is not linear with velocity. The velocity means it's more force, that means there's more friction. No doubt about it. Going slow means lots of friction. Going fast means less friction. No reasonable, logical person should disagree. And the only way they can disagree is because they're Muslims. They're fucking fanatics. They don't give a fuck about the truth. All right, so I mean, can you get any sillier? The spring deflects less, but that doesn't mean there's less pressure. I mean, so springs don't detect pressure? What do they detect? Hummingbird wing wind? I mean, what it's so fucking silly because, as you can see, the scale doesn't change the weight. The weight isn't anything. Weight isn't a real thing. Mass is a real thing, fucktard. Weight is an emergent function. Weight is exactly bending a spring. Weight is applying a pressure. Weight isn't mass. Weight is momentum. I mean, I really am stunned that they just can't, they can't connect that weight is imposing, momentum. That momentum and weight would have to be thought of as being very similar things. How could you separate weight from momentum? Oh, amazing. Let's see, the spring during the short time it's being deflected is being pushed by the same pressure. So that's just, there's no point in talking to these people, right? Obviously the net pressure is not the same pressure, so it's just a lie. So just keep making up crap. It's per foot. We're making an argument that there's a certain amount of linear space here, you moron. And clearly the pressure on this amount of linear space will not be the same. Does the spring change the weight or not? So they just keep talking in circles. The spring is measuring the weight. It's measuring the momentum. I could move the scale this way, and I can measure momentum with a spring. I just, there's just no hope. These people really are... they're worse than the religious kooks. Because, frankly, I wouldn't think a religious kook would say something this silly. Let's see, the fact that it deflects less is an artifact of the fact that it reacts slower. So, if the ground reacts slower, can it still absorb the energy as friction? I mean, it just doesn't make any sense. And if I go fast enough, I don't touch it at all. Does it still react slower, even though I'm not touching it at all? I mean, the argument being made is that you're saying that friction is linear, and it doesn't matter how fast I go across the surface. Well, if I go really, really fast, I barely touch the surface. How could I lose all my energy if I didn't touch the surface? How could I lose energy to the surface if I don't touch the surface? So it's probably worth just blocking you, right? It's not that complicated to understand. I mean, this is ludicrous. You saying that to me. It's ludicrous. I mean, what did you think? I mean, it's right here on the board, moron. Half the speed, 3/4 of the distance. All right. The pressure during the time it's deflecting the spring is the same. How could it not be? So again, it's the amount of pressure per square inch or per linear foot. This is what this thing is measuring. It's measuring that based on the size of this plate on top. I make the plate smaller, I'll get different numbers. And it's a proportion. It's saying there's less energy hitting this surface. There's no way around that. You're just playing an insanely silly word game to pretend we know the net amount of energy is less. The spring absorbed less energy because less energy was put into the spring. Okay, measuring doesn't mean change in weight, so this is more nonsense. Of course, this measures, okay, momentum. Again, I could just put it this way, and I can bang objects into it, and it measures their momentum. It's a real thing. The pressure. Let's see. Because you can't provide a counter argument to what I said. So, okay, I'll just block you. No point. I don't think the weight changes. Yeah, I'm just saying the weight is what the scale is measuring, and obviously the scale will measure a different amount the faster I go. So it's a non sequitur say the weight doesn't change when it clearly changes. Weight isn't mass. I mean, you keep... is that where you're confused? You think mass is weight? You don't understand that if the spring reacted faster, then it would deflect just as... It's a different spring then. It's not the same spring. What are you talking about? Yeah, I could put a lighter spring on and it'll deflect the same number of inches, but that wouldn't be measuring the same pressure, idiot. It would be measuring the pressure wrong. Of course, I told you the weight isn't a real thing, you shithead. It's the amount of pressure hitting the scale. The weight is the amount of pressure hitting the scale. It's measuring it. That's what the scale is measuring. That's what the spring measures. It measures its weight. The clear argument is the faster I go across the scale, the less weight hits the scale. Weight is not mass. Oh, God, you're stupid. All right, I'm not going to... They're all calibrated. Okay, I'm just going to block. This is just a troll. He's just wasting time. So I guess that'll be the test, right? So anybody who wants to comment in this comment section, if you won't concede that the faster I move across this scale, the less contact I'll have with it, the less pressure I can put into it, the less energy will go into it. Gravity will collect less. There'll be less energy in the pressure, less friction, and less energy absorbed per linear distance. If you can't concede that's true, then don't bother commenting. Because it's ridiculous. It's just fucking ridiculous. I mean, you really believe the scale will weigh, it'll register the same weight no matter how fast I go across that surface? That's the simple question. This little arm will register the same thing no matter how fast something travels across this surface. That's the argument. Nothing else. If you can't concede, yes, that's true. The faster you go across the scale, the less energy will get into the scale. If you can't concede that's true, there's no point in talking to you. I mean, it's as solid a physical fact as you could possibly get. If you go 50 miles, okay, good, you deleted it. Good idea. Jeez. Such a... I like I said, I never realized in doing this project, I thought, you know, intellectuals they have integrity, they're honest people, this will be great fun. I'll make these arguments and they'll have to concede the arguments and they'll, you know, no problem. But I just never realized that smart people are liars and fanatics and kooks, and they won't concede anything. Doesn't matter how much evidence you put in front of them, they just don't care. I mean, it doesn't matter how much you demonstrate the physics to be kind of fake and phony. You know, 400 times better resolution from space. The experiment takes 5 minutes and you don't need an eclipse. And they've never attempted it. And they can't concede. Boy, that doesn't make any sense. One of the most famous experiments in the history of science, and they didn't repeat it? With 400 times better seeing? 400, you can't even imagine 400 times, right? I mean, 400 times better vision? You can't even imagine it. Okay, well, you know, obviously you're the one with no evidence. So again, and I've just pointed out, you can't admit the obvious. So, V-tails, do you concede that the faster I can make something go across this scale, the less I can make it weigh? Do you concede that or not? Yes or no? So that's your blocking test. Yes or no? Do you concede that's true, or yes or no? Or prove you're the coward. You won't answer the question because you're a coward. A weasel. Block the dissenter. So I'll ask you, Simon. Go ahead, answer the question. Yes or no? The faster I go across the scale, the less something will weigh. Yes or no? I am showing your arguments. These are not arguments. Where's your argument? You don't have an argument. You can't link me to your leader. You can't link me to your evidence. You can't link me to anything. And you won't answer simple questions. There you go. Okay, so Simon, you've conceded an elemental argument. An elemental argument that destroys the notion that friction is linear. And that I lose the same energy per foot. And that measuring distance is a way of measuring how much energy I lost. And so when it goes 4 times further, when it's rolling, you can understand that it doesn't have 4 times the energy. because I didn't pull the energy out of it at the same rate I pulled it out of the other object. I pulled the energy out at different rates, and that's why they rolled at different distance, is because I extracted their energy at a very different rate. So it's fundamental to the argument, and in my opinion, you've just conceded 80% of my argument. You've just conceded that 4 times the distance is an illusion. It doesn't represent 4 times the energy. If you go 50 miles per hour versus 5 miles per hour with the same weight, I don't know what that means. How can you have the same weight? It's the same mass. The one going faster will weigh less. You have to say the same mass, and the one going faster will weigh less. Your weight is a measurement of an event. Weight is an event. Mass is a thing. The fact that I even have to do that for you people. I really shouldn't have to do that, right? I shouldn't have to explain to physicists that weight is an event. Yeah, I shouldn't have to do that. Seems to me that the faster you go across the scale, the less energy you lose to friction per unit distance. Right, so that's him conceding the argument. Good. I've spent less time on the spring scale. It spent less time on the springy scale. Yes, and because friction is being created by gravity, right? This isn't a friction being created by somebody squishing something. This is a friction created by gravity. And the time you spend in the gravity will decide how much weight the gravity gave you. That's the whole point. So the less time you're in the gravity, the less you can weigh. Yes, time is the whole point. Oh, amazing. Amazing. It's a time-dependent, time-controlled force. Oh, do we all agree? Well, anyway, I don't think we all agree, but whatever. I still haven't seen Merker say anything. So they all concede that if I'm using friction controlled by time-dependent gravity to measure or extract energy, so I'm using friction to extract the energy of the object, that the fact is it won't extract it linearly. It won't be the same amount of extraction here as there is here. And because of that difference, this will be given the latitude to roll further merely because it's going fast enough to evade the friction. But it's the same energy here and here as there is here. This only has 2 units of energy, not 4 units of energy. And there only was 2 extra units, and there's only 2 units of energy put in to make this go twice as fast. Not 4 units of energy. I'll start editing Wikipedia to affect this new understanding. So you're just being sarcastic. I'll start, editing Wikipedia to point out who Leibniz really was, right, and what he really believed. So let's put it right on the Wikipedia page where they talk about Leibniz, and they'll just start talking about monads and solitons. And his direct quote written to a friend that he thought Newton and Descartes were too atheist. Their physics was too atheist. Maybe that should be on the Wikipedia page. And on the Deschardelet page, maybe they should put, she was tutored by a Leibnizian who actually sued her for plagiarism. Like, that might be an interesting context to why she was a believer, is that she was personally tutored. She never went to school. She was tutored. And she was tutored by a Leibnizian who sued her for stealing his Leibnizian beliefs, stealing his religion, plagiarizing his religion. Was Leibniz is the guy accused of stealing Newton's calculus, that is, using calculus and then claiming he discovered it when in fact Newton had discovered it 20 years sooner. And then he forged documents to attempt to prove that he was the originator. So when the argument started getting heated, he got desperate enough to forge some documents to pretend he wrote to somebody in the past about this subject when he didn't. So he died a nobody. Nobody even, he basically had to get, one of the families that used to pay him to be their personal scientist paid to bury him, but they weren't obligated. But no one went to the funeral. And I mean no one. No scientist, no one. No one was there. Newton was buried as a god. He fundamentally disagreed. Yes, Newton claimed energy was mv. Quality of motion was just mass times velocity. Leibniz said, no, the quantity of motion was mass times velocity squared. Leibniz invented the kinetic energy theory. He was the first to propose it as a truth. And in the first 40 years, nobody, except a few kooks, fell for it. Because they all said, that's a free energy theory. Now levers make free energy. That's what they said. They said it. By your theory, levers make free energy. And then Leibniz said back to them, well, by my theory, your theory makes free energy. But obviously, everybody just kept saying, it doesn't take 4 times the fuel to go twice as fast, you motherfucker. Quit saying it does. That kind of thing happened. And then they did some clay experiments in the 1740s, 1738 or something. And because they dropped round things into clay, everybody got snookered. Because it looked like the 4 times the distance thing again. It looked like the rolling ball going 4 times the distance, and the suckers fell for it. So why does almost anyone favor Leibniz KE rather than Newton's MV if Leibniz was so unpopular? Because Deschardelet, a slut, was very popular in France, 40 years later. She became the thing. And, she became legend. She had a big pile of money and she was a slut. And again, everybody fell for dropping round things into clay. Like I said, you roll the ball, it looks like 4 times the energy, right? What are you going to say? It doesn't look like 4 times the energy. It rolls 4 times further than twice, right? I mean, it's supposed to only roll twice as far, and it goes 4 times as far. Because stupid people will fall for things. There's nothing you can do about it, okay? I mean, maybe there's some stupid people who don't think pointing an arrow, makes it go into objects deeper. You know, I don't know. But yes, I mean, that one they really should get. Didn't a fan of Leibniz promote his work and tarnish Newton's work? I don't know what you're saying. No, I guess I would say not until much later. But I mean, the irony of the Deschardelet woman was is she believed in both, so she loved Newton. I mean, she thought Newton was great and brilliant, but she didn't even realize that she was basically contradicting an elemental belief of Newton's. So that was sort of an ironic twist to the whole thing, is why she's promoting Leibniz's mv squared. She's writing a translation of Newton, so more people can read Newton. I mean, it's ironic. It is sad that history just disappears. I mean, I used to be able to, I don't know if somebody else can find the link. There was a link to the actual journal that Eddington wrote while he was doing his eclipse experiment. And in the journal, he's saying how I wouldn't stake my life on these results. Everything went wrong, blah, 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 blah. And I can't find that document anymore, which is really irritating. Yeah, so I mean, Deschardelet wasn't exactly debunking Newton, but she wasn't very. I mean, frankly, you have to be pretty stupid not to realize you're attacking one of Newton's fundamental beliefs. Now, I'm just saying, if you read the actual history, it's makes science look goofy, okay? Because the arguments did suck. I mean, they start making these convoluted arguments. Well, you're on a sailboat and you push a duck at 3 miles an hour, and then you step to 4 steps to the right, and then hop 3 steps to the left. And I mean, they're this so if you go actually try to read what they wrote, you almost can't follow any of it. It's so convoluted in their desperation to try to defend both theories. I mean, both the arguments sucked. They absolutely sucked. Yeah, well, none of this is appeals to authority. I mean, the point is that it's shitty science, and you people won't concede that it's shitty science not to repeat the Eddington experiment, right? An experiment where the guy admits, I wouldn't stake my life on these results. Well, shouldn't the results of that are going to decide a truth, shouldn't you be willing to stake your life on them? I mean, you shouldn't be arguing something you're not willing to stake your life on. I'm willing to stake my life on it. I'm willing to be gutted in the public square, okay, if you people can prove your wacky verse to be actually true. Because I don't think there's any chance you're going to do that. But obviously, you've got to understand the context of everything, right? And so the changes that were taking place, the whole political thing, all of these things affected these results, right? I mean, the reason why Eddington got to do the experiment was because they were trying to prove Einstein wrong, right? So that's why he got funding to do the experiment, was because everybody who was funding the experiment, the Academy, was complete Newtonians, and they hated Einstein. And so the only reason why they funded the experiment was to actually prove Einstein wrong. Eddington convinced them, even though Eddington was way up Einstein's ass, Eddington convinced them that, oh, come on, there's no way they're going to be able to prove this, and blah, 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 blah. So let's do the experiment. So he basically snookered the Newtonians into financing an experiment to basically prove a German wrong in the middle of World War One. I mean, that's the context. I'm just saying, you got to understand the context. The British hated the Germans, And from their perspective, Einstein was just a German. Now, even though Einstein didn't want to be he wasn't very German. I mean, he didn't want to belong to any country. Well, Wikipedia is clearly not, okay? It isn't like it's the most accurate. It's always, to some extent, inaccurate, frankly. It really doesn't fact check very well. It just does the popular thing. I mean, just like the chat bot and all the rest of this stuff, it's just a popularity engine. Majority opinion wins, and that's what you could say sort of happened to science. The stuff you could convince the more people of, the more people who believe it, the harder it is for the dissidents to have their voice heard. So I'm just saying that, in Newton's time, there were lots of people to defend against, mush. And so the mush got eaten up by the Newtonians. But the further you got from Newton's death, the more possible it is for somebody to resurrect crap and make the cult work. And that's all they did. Like I said, they had a little gimmicky clay experiment. They had the little gimmicky roll a ball on a surface. And those two experiments are pretty convincing if you're just going to go by what does it look like. But this is just as bad as comparing water waves to photon patterns. It's a ludicrously silly way to do science. It looks like a water wave. Well, no, it doesn't in the single slit, and no, it doesn't in the multi-slit. So you're just picking one little place where it's the same. I mean, it's just so bad. It's just rotten science. I mean, appeals to populum are just as bad as appeals to authority. Everybody believes it, so you must be wrong. The appeal should be to evidence, and you should be able to, all you people should be able to admit they really should have repeated the Eddington experiment by now, especially with the 400 times advantage from space. Everybody should be able to admit that. There shouldn't be a single voice saying, oh no, none of that's necessary. That wouldn't really help any. Nobody should be saying that. Everybody should agree, yeah, they should have repeated that experiment from space. Hell yeah. Nobody. There should be no dissenters. I mean, you should even be able to concede a little bit that maybe it's a little bit silly to compare water to light photons. But this is all agenda, and it's the etherists are alive and well. I mean, ironically, Einstein was an etherist. I mean, basically conceded, if you can warp space, well, then it must be something, not nothing. Alright, well, I guess we've run our course and such and so forth and whatnot. So I will prepare for my exit. Let's see. I have to go here. 14. Okay. That's a little better. 14 viewers. And let's see if we have any last word from the viewers before I go, because they're really not saying anything yeah, useful. But anyway, it's surprising that KE formula is so accepted, yet there is no evidence that can be repeatable to demonstrate KE. It's just that the evidence is in all these experiments that are subtle. And it's not in any experiment where it's not subtle. So crashing the cars, not subtle. No evidence of it. Crushing clay, not subtle. No evidence of it. Dropping round things in the clay, subtle. Okay. And then the banging the cart thing's just kind of obvious that, it works when there's a spring. So in a super elastic experiment, it works. In a elastic, that is hard object against hard object, it doesn't work. Why should that be? And then the question would be, well, the whole thing is about springs, right? So if I'm going to, I've pointed this out, but I mean, if you're going to make a spring that's going to collect energy, scales are a real problem. All right, I love scales, and it's a great idea. But you do have to concede that, if I turn the scale upside down, and then I bang an object into it, well, then I have to give this scale momentum. And that's different, right? Now I'm forced to move the whole mass of the scale. And then you could argue that, if I have a plunger and it hits something, if I compress a spring and then I bang the spring into something, like let the spring start to get velocity, that is, this piece gets momentum, and then I bang its momentum into the object, I'm going to get a different velocity than if I put the object on the scale in full contact and then push it. So pushing and hitting are two different things. So that's the subtlety of all this, right? So all the experiments where they having this KE stuff work are ones with all kinds of subtleties that can be finagled. You could do the scale this way, or you could do the scale this way, right? All kinds of subtleties. You could have a big banger, right? Big banging surface or small banging surface. You can hit the object or you can push the object, right? These are all subtleties that can be finagled to get whatever answer you want. Again, an air track, the theory is good in some respects. Like, yeah, sure, I'm defeating the friction, the contact, but how am I defeating it? Oh, I'm supplying a whole bunch of new energy. So I'm pushing a bunch of new energy into the system. And if that energy, if the cart tilts at all, that energy is going to show itself. So it's, again, a subtlety. Okay, you have to be sure that your air track is made well enough to isolate itself from its defects. And so that's all this is really. So again, when the iron guy did the launching thing, and he had 5 springs. I think there's 5 springs, not tied to each other. Okay, and he's using the compression of 5 springs. So he's using all the unevennesses you can imagine, where the springs aren't really pushing on each other very evenly. You can understand that one of them has more of a spring constant than the other, so when it releases the energy, it's going to push the other springs apart from each other. Lots of things that can go wrong. He didn't tie the springs to the base, so the springs themselves will get launched. Lots of reasons to say, hey, there's lots of variables there that you have to control for. So, yes, what I'm saying is clearly what they don't show us is experiments that don't have a lot of mushy variables that can be finagled. And the experiments they do show us a lot of messy variables. I mean, I'm just saying you can't go too wrong with some experiments, right? So I'm just saying even if the Mythbusters hadn't compressed clay, and instead just used a spring, and just had the weights hit the spring, they would see that two 50-mile-an-hour cars do compress the spring as much as 100-mile-an-hour crash. The spring in the middle will feel 100 pounds of pressure, not 50 pounds of pressure. I mean, simple things like that they don't do. You're just saying how stupid of them not to realize that what they want to do is put one piece of clay and hit it with the two hammers. They don't want to have two pieces of clay because then the compression is spread over two pieces of clay. Of course it's going to be half as much. I mean, it's just, you're saying that those guys are not stupid, and the very fact that they couldn't figure out that, well, if I'm measuring it with two scales, right, if I bang two scales into each other, I'm only going to read half the pressure on each scale. I mean, you know, that's pretty stupid. I mean, it's a pretty big oversight, or whatever you want to call it, but that's all. It's physics, and this isn't that much fun to be able to sit there and, you know, understand every time you do something that you could be, you know, I tie it to a string and, oh, I forgot it has some motion this direction. I mean, when I did the ballistic pendulum thing, I didn't anticipate that when the two pieces of steel would hit each other, that there would be some rotational energy just from the fact that they can't hit on their center of mass perfectly. So they're always going to hit a little bit off, and that little bit off means they're going to turn a little bit. And then the turning is going to make it impossible for me to do a frame rate because now they're, you know, because they turned, their length has changed. You know, little subtle things like that. I mean, it's a pain in the ass. But that's science. Science requires all of these details to be managed responsibly and on purpose. And what you clearly see in physics now is, who cares? Details, smeetails. Just create a theater. Show half the experiment. Draw it sloppy as you remember Feynman's drawing of the double slit experiment. I mean, it has this really precise pattern, and the two patterns are so precisely different from each other, and he just draws slop on the board. No, it's just this sloppy wavy stuff. No, that's not the experiment. Scales are calibrated by scale, so I think you're, you know, I don't know what you're saying, but I think that's pretty much, and they have a little thing on them right here to calibrate them, you know, so you can adjust them. But anyway, yeah, you didn't answer my question, Merker. All scales have some inaccuracy. I don't know, relevant inaccuracy? What are you talking about? You're saying I can't make a scale that's really precise? You know, like hundredth of a gram? I think they can, shithead. Just like you can make a clock that's really reliable. So you're just talking shit. None of this unreliability or inaccuracy has anything to do with these experiments. I mean, a 0.05 error is nothing in these experiments. Nothing. Meaningless. I mean, obviously you wouldn't want me to do the experiments with this fucking piece of shit scale. Obviously this is not accurate enough, okay, for some experiments. But it probably could handle me dropping 5 ounces versus dropping 10 ounces, and it'll be able to tell the difference. Oh, whatever. People. They're just going to keep trying to weasel out of the obvious statement. It's not been good physics. Good physics has not been good science. Sloppy, sloppy, sloppy. Anyway, till the next time and such. It looks like a religion. It quacks like a religion. It walks like a religion. You know, blah, blah, blah. It's, you know, more religion than science. So, till the next time and such, and so forth and whatnot.